is physically as well. I think the last time we had like a guest from PSC, I think is EKL 2023, and also like for online, it's last year I think around February. Yeah, so glad to have you guys. Then after that, we're going to have Q&A and also makan delay. Yeah, is physically as well. So I think the last time we had like this last time already. So this weekend, there's PSC, I think it's session is the EKL 2023, and also like for online, it's last year I think around 1:30. Yeah. So if you guys want to go and to go to Penang, and after that we're going to have Q&A and also makan delay. Okay, so this one is for online meetups. This one is physically as well. So I think the last time we had like this last time already. So this weekend. There's like verification session is for EKL 2023, and also like online, it's last year around 1:30. So if you guys want to go to like research paper to go to some of the scholars have Q&A and also makan delay. Okay, so this one is for online meetups. This one is physically as well. I think the last time we had this last time already. So this weekend. There's verification session is for EKL 2023, and also online, it's last year around 1:30. So if you guys want to go like research paper during some of the scholars have Q&A and also makan delay. Okay, so this one is for online meetups. This one is physically as well. So I think the last time we had this last time already. So this weekend to you guys. Okay, so it's for EKL 2023, and also like online. It's last year around 1:30. So if you guys want to go like research paper during some of the scholars this year and also everyone have okay, so this one is for online meetups. It's physically as well. So I think the last time we had this last time already. So this weekend to you guys. Okay, so it's for EKL 2023, and also like online. It's last year around 1:30. So if you guys want to go like research paper during some of the scholars this year and also everyone have already. So this is for online meetups. It's physically as well. So I think this is not to you guys. Okay, so actually it's for EKL 2023, and also like So yeah, for example, this is an example, right? Yuroitaki posts a website called fc-post.net, and they coded some logic for they coded some logic using the following the Farcaster frame documentation. Because is water healthy to drink? Is it healthy to drink water? Yes or no, right? If you click on yes, go to the next slide. You click on yes, it can tell you how many vote yes, how many vote no. So basically, it's adding interactivity for any site that posts as cast to Farcaster, right? I think it's exciting in the way that it unlocks some new capabilities for any apps to have instant interactivity through a social app itself. It's actually using an open protocol, open graph protocol developed by Facebook last time. So they hack it some way so that it can be interactive on Farcaster, right? Something new, I think we started this hackathon just want to get more people to just hack around, try out some decentralized social protocol, social media protocol. Social media protocol basically like Farcaster. Although you need to pay technically for I think $5, right? Is it $5, something like that? $5 to actually get access to Farcaster. It used to be free last time. But try it out. Farcaster is something new for everyone. And try out Farcaster, try out Frame, find a way to code Frame it's free. It's not hard as well. We will release the requirements in terms of actually what are the requirements, what are the evaluation criteria for frames. And basically that's it from my end. Yep, that's all.
Sorry. Oh, yeah. Forget to mention, we are giving 1,000 ringgit as cash for the winners of the ETH frame hack. Yeah, basically that's it.
Specifically the EcoDev team. And what I'm going to do before Chris goes ahead is give you an overview of what the PSC is doing, specifically the acceleration program. And if you guys have any questions, feel free to just give me a shout. Is this? Oh, okay, closer. Got it. Got it. Yeah, let me just make sure I've got this microphone set up and running. Cool. Okay, so go to the next slide. Yeah, so we'll start with what the PSC is. Sometimes people get confused about this. So everyone here has heard of the Ethereum Foundation. So the Ethereum Foundation has a number of teams within it. We have the ESP. So if you've gone for a grant, that's typically done by the ESP. There's a Solidity team. There's the Geth team. And within the EF is the PSC, which is the Privacy, Scaling, and Exploration team. So that actually happens to be the largest team. And within the PSC itself, you have essentially kind of like two main areas. You have the teams that work on the research and the protocol, and then you have basically the teams that work on getting that research out there for people to use, for developers to know about, and that kind of stuff. So today you're going to hear Chris talk about TLSNotary, and TLSNotary is one of the 38 different protocol teams that are within the PSC. And yeah, so you'll get to hear that from him later on. With that said, before I go ahead, does anyone have any questions about EF, PSC? We can make this a bit more interactive. I don't have to go ahead. Okay, cool. So no questions. So we can go ahead to the next slide. So I want to talk about the acceleration program. So we have a number of different programs within the PSC that are there to help promote people to learn about the different types of technologies that are being developed. One of those programs is the acceleration program. Can we go to the next slide? Yeah. So the idea behind the acceleration program is it's a grant-based program where people can come along and pick up tasks, and by completing the tasks, they essentially learn about something in the programmable crypto space. So that could be MPC, so multi-party computation, which is what Chris will be talking about. That could be ZK-related work. That could be FHE, fully homomorphic encryption. And by completing that, the idea would be that you would learn a bit more about the space, and by doing so, hopefully further your journey into pro crypto and become a researcher or developer yourself. Next slide. So yeah, so the reason to join would be to learn more about the space in a way where you're also kind of compensated for it. There are, honestly, the PSC itself, and specifically the EcoDev team, when we put together these programs, we try to make them as open and as free as possible, and if need be, also give grants. So yeah, so it's a great way to learn, and you should definitely give it a shot if you can. Yeah, so I'm going to go over a few typical questions around what the acceleration program is like. So if you're wondering what this actually looks like, if you go to the acceleration program GitHub repo, which will have a link to it, there'll be a list of different tasks that you can do. And when you pick up these tasks, each task has like a description of what it is, what you need to do as someone that's taking part. And once you've done that, you can basically apply through it through GitHub. And once you've gone ahead and applied, you can essentially work on the task and unlock unlock certain grants based on kind of progress that you make. Can we go to the next slide? So The funding itself is somewhat variable depending on the different kind of tasks there are. Some are more complicated than others. They take a bit longer than others. But yeah, so there's a variety of ones. Some which might take you a couple of days. Some might take you, much longer than that. But yeah, so ideas again, take part. It's a free project. You can learn about kind of the work that we're doing at the PSC, and that's basically it. So yeah, so if you're wondering who it's for, the acceleration program itself is designed for people that have some background in ZK, MPC, FHE. So you should know a bit about how it works. You don't have to be very proficient. That's not what it's designed for. We have other programs for that. And actually, within the PSC, we have a range of programs for people that are starting their journey. We have programs for people that are far more mature in their journey, which is beyond the acceleration program. And then we have basically the acceleration program, which would fit in the middle. So you're kind of like a developer that knows how to code. You maybe read a few papers here and there, and you kind of want to get your hands dirty. So it's open to everyone, but there are a few prerequisites. When you read the tasks and you read about what you need to do, you should be able to kind of really understand that. And yeah, we can skip past this part. This is kind of like the methodology behind how it all works. But yeah, if you're interested, just scan the QR code, and I'm on ETHKL Telegram, so you can also just hit me up anytime. If you have any other questions that are about programs that the PSC is doing specifically, you can hit me up as well. We have a bunch of different things coming up, hackathons, other bounty-based programs, and also opportunities in PSC. Just give me a shout. Okay, I think we can, yeah. So we can basically skip through the rest. There's just some additional information about how the grant program works and what it would look like. But that's it for me. Yeah, if you're interested, just scan the QR code or just text me. We can go from there. Sweet.
Vice, need to set up video on here. I just leave it.
Oh, I think I just look up.
Yeah, I think I got this.
When you change the thought.
Yeah, she's supposed to have to set it up here now.
But then the New Year's game.
Oh, I see. I just realized I may have had it the wrong way. The microphone's here.
I look, it's not this one. It's always the one that you can see the position standing. No, it's okay. I will have to press my. There's a lot of different. Thank you. Thank you.
And the con here.
This one? Yeah, can you send it?
It's one.
Do you wanna click this on?
Yeah. Yeah.
Yes, I'm excited.
Yeah, it's fine. So that I know this yeah.
Okay, so right now I'm going to pass the mic to Chris, the main the main person of the event today. Okay, here you go, Chris.
Thank you.
You can just put this here.
It's easier. Okay. Okay. Test. Okay. First of all, thanks everyone for coming to listen to this talk. And I was planning to talk about just intro a little bit about what TLSNotary is in terms of like who is managing this project and who is the organization behind. But Mo has done a pretty good job in introducing PSE and EF. So if you pay attention just now, I shouldn't have to repeat myself. So I'm gonna skip past this. But yeah, before I do that, I think I pretty much know everyone here except for a few. Chris here, and a bit of background. I joined TLSNotary about 8 months ago, and was working on the more application level softwares to demonstrate how to use the core libraries. But now I've also moved on to work on the core library itself. So yeah, without further ado, let's go through some agenda. We will start with some overview, just a simple introduction to what TLSNotary is, and then some use cases, why you should use TLSNotary. Then a bit of technical dive into how it works. We'll follow up with a demo to show you how to use TLSNotary in a browser. And then finally a Q&A. So I also figure out there will be times where I will stop and ask if you guys have any questions so that it helps with your understanding because it's built on top of each other. Built one after the previous portion. So it'd be good if you have any question, you can just fire away whenever I stop for question. So overview. To understand TLSNotary, I think it's important to understand what TLS is. And for those of you who don't know, it stands for Transport Layer Security. It's basically the security protocol that guarantees the security between two parties that communicate via the internet. It's the green lock and the S in HTTPS that you see on your address bar. And by security, I mean it guarantees two things. So it guarantees the origin of the data, which means if you are connecting to Facebook.com, you can be sure that you're talking to Facebook.com and not somebody else pretending to be Facebook.com. And also it guarantees the integrity of the data where someone can't just intercept in the middle and change the data to lie to you. So whatever you receive from Facebook.com, it's the authentic data. What's missing in TLS is this thing we call data portability, which means you can't just take the data that you receive from the server and then prove it to a third party like Bob right away. So to explain it using an example, let's say I'm Alice today and I want to borrow some money from Bob, who is a lender. Usually I will need to go to my bank website and get the bank statement and then pass it to Bob because Bob want to know that I have enough money in my bank to pay for installment. But Bob can't just directly trust that the bank statement is valid because I can fake it or I can just, forge it. So Bob usually would have to check with a third party or the bank itself to verify that this statement is true. And that's exactly the problem because with third parties, sorry, technical issue. Is it? Yeah, okay, there you go. Oops. Maybe we have to. Yeah. Yeah, maybe the adapter can work. Yeah, can. Allow. Where's my mouse? Okay. Yeah, sorry for the technical issue. I was talking about Alice and Bob, where Alice wanted to borrow some money from Bob. So Bob can't just trust the bank statement that Alice gave it to him because it can be fake, and that's where the problem is. Because now, if we use a third parties like OAuth, for those of you who know about OAuth, is a technology that allows a third party to access some data with some permission from the user in a server. It's not too important to know what exactly it is if you don't know, but essentially it's a third party that checks or allows, that enables user to check data in a certain server. And this is not good because the third party now can see your data, can see the bank statement, and which means you don't have privacy, that you lost privacy in that sense. And also, if you don't use a third party, if Bob is checking directly with the bank, there's also some loss of privacy because your bank statement might contain more data than Bob requires, because Bob only wants to know your bank amount, like as in your bank balance amount. But maybe Bob doesn't need to know your address, but your bank statement has a lot of other information that Bob doesn't require. So you also lose some privacy in that sense. So that's what TLSNotary is trying to solve. It guarantees origin and integrity because it writes on top of TLS, but it also guarantees portability, which means now Alice can just get this bank statement proof generated using TLSNotary, give it to Bob, and Bob can directly trust it and use it. By use, I mean give the loan to Alice. And doing all this while maintaining privacy. So there's no third party here. And also TLSNotary allows user to prove only the necessary data to Bob. So Alice can only review her bank balance without revealing any other unnecessary information that are sensitive. And the beautiful thing here is that all of these are transparent to the server. So the bank website doesn't need to do any changes, nor it knows what's going on. Like to the bank, it's just a normal user requesting for data. So all these are transparent to the server. Let's go through some use cases. And I guess this will make it even easier to understand and appreciate why you should use TLSNotary. So one example is this independent anonymous review website. Today, if I'm Bob and I want to buy a phone from Shopee or, I don't know, Taobao, whichever e-commerce website, and being Bob, I am a very cautious buyer. So I want to see a lot of reviews and I want to trust those reviews before I buy a phone. But I can't really trust those reviews because, I might be thinking that those reviews are not real one, like they come from fake buyers that's incentivized by the seller to like put in good reviews so that people can buy their product. And also, I don't know if those reviews are honest. Like even if that guy has purchased the item, I don't know whether they are brave enough to put like a bad comments if the quality of the product is bad. So I have a pain here. And TLSNotary can come to the rescue by having this review website using TLSNotary. And how that works is the user who has bought a product from Shopee or bought a phone from Shopee can generate a proof of purchase from Shopee without Shopee knowing, because as I mentioned, all these are transparent to the server. So Shopee doesn't know this is ongoing. So Shopee can't censor Alice from doing this. And the review website now can accept this proof of purchase from Alice and nothing else. So they don't have to know Alice's name, any other credentials, because the proof of purchase is a guarantee that Alice has purchased a phone from Shopee. And this enables Alice to leave a comment without revealing her name if she doesn't want to. So it's an anonymous review. And usually for some people I know, including myself, I feel more comfortable leaving especially negative reviews if on a website, on the public, if it, I might be afraid that it might affect my reputation. So if it's an anonymous review, then I can be at ease leaving my most honest review. So now Bob is satisfied because he can just trust that website has all reviews from actual buyers because he can see the proof, as well as those are honest reviews, at least with some confidence. And there are a lot more use cases because any data that is stored in a server that uses TLS can be proofed. And that's almost everyone that uses, almost every server because everyone uses HTTPS. So you can think of use cases like proving your identity, like your age or citizenship, to a verifier without the verifier needing to check with the government or like some sort of authority, which might have like censorship risk. And you can also prove like financial data, like bank transfer, like you make a bank transfer or you receive a bank transfer. So there are some guys that are building a on-ramp app using TLSNotary so that they can prove that this user has made a bank transfer to someone, and then they can release fiat. Sorry, they have made transfer of fiat to someone, and they can release crypto from the smart contract to that recipient. And all this without going through the bank, because going through the bank would be a pain, and you want to get them to check certain transactions. They'll cost time, as well as there's also the censorship risk. And then finally, you can prove reputation, that you are an owner of a Twitter account or Reddit account that has some amount of followers. And this is quite useful if you have some sort of dApps that maybe only allow well, this is just an example. Like if you want to make a chat room that only allows Steam players with certain number of gameplay on CS to join, then you can use TLSNotary to ask for the proof. So how does it work? I guess this is the thing everyone's waiting for, hopefully. It's the interesting bit. Let's do a bit of role check. Mention Alice and Bob and server. So there's quite a lot of different entities. Let's standardize the term that we use now onwards. Server still remains a server. It's basically the entity that holds the user data. And then you have prover, who is essentially just user. Is that person who wants to prove something about that data that's stored in the server. And then you have verifier, who is just the application of someone who wants to check certain facts about that user data. So to use the example that we have, different examples that we used just now, server is Shopee, the prover is that Alice person who just bought a phone. I want to prove that she bought a phone. And then the verifier is that website that want to check that that user has bought a phone. So yeah, just keep this in mind. What TLSNotary is not, it's that it's not a man in the middle. So this is actually an easy way out if you want to have the verifier to verify certain facts about the user data in an easy way. So we can just put the verifier in the middle, and then this verifier just listen to the data requested by the prover from the server, and then just, he can just look into the data and then verify that this user has like 1 million ringgit in his bank account, and done. But then this is definitely not ideal and like very bad, because you sacrifice privacy, and also you have like a lot of security risk by putting a man in the middle like this. So this is not how TLSNotary work. And to understand how TLSNotary work, we have to go back to TLS. This is a very simplified version, but TLS is essentially about encrypted communication, i.e. you have to make sure that the data that you are sending back and forth between the user and the server, the prover and the server, are always encrypted, so that no one can, in the middle, can come in and try to like change the data. And to do that, you need keys to encrypt and decrypt, which I believe most of you are pretty familiar with. So you have these two keys here, purple key and orange key on both sides. They are essentially the same keys. These are the keys that the user used. The orange key is the key that user used to encrypt the request and send it to the server. So the user want a request for like a bank data, right? So they encrypt this request with the orange key, send it to the server. The server decrypt that request with the purple key and gets the request plain text and understand that the user wants some information. And then the server will encrypt the response with the purple key again, send it back to the user, user decrypt it with the orange key, get the response, which is the bank balance. So remind you again, the purple and the orange key are the same keys. They're just kind of distributed to these two parties. And that is done by the first stage called key exchange, which there is some magical cryptography happening in the middle there, but I'm not going to go into the details. But I just want you to know that the outcome is that these two purple and orange key are the output of that key exchange stage. And the purple and orange key are the same keys, just to reiterate that again. And how does that look like in TLSNotary? So on the left, on your left, the server side is still the same. You still have the purple key, everything is the same. But then on the right side now you have this extra entity who is the verifier, who is that application who want to check the user data. Now that verifier is involved in this key exchange process, and the outcome of this key exchange process, and again let's focus on the outcome, is that instead of one orange key like the previous slide, you have these two keys, which is the yellow key and the red key. They're kind of like half of the orange key. So each of them is like a split half of the original orange key. That's why you see that orange equals to yellow plus red up there. So now this prover or this user no longer has the full orange key. He only has half the key, and the verifier has the other half of the key. And I will explain why we do this later, but then the way you do this in terms of deriving this half keys or splitting this key into half is done using MPC, which is part of the title of the talk. And it stands for, it stands for Multi-Party Computation. 2PC, it stands for two-party computation, and essentially 2PC is just a special case of MPC, where 2PC just involve two parties and MPC has more than two parties, or can have two parties or more than two parties. And what it does is quite simple, like on a high level. Basically, you have these two parties that tries to compute a function together. A function can be imagined as like a software, but this software depends on two inputs from each of them, as in it requires some input from one party and some input from the other parties. And these two parties they don't trust each other that much, so they don't want to reveal their input to each other. So they want to keep their input private, but at the same time, they want to generate the output together. So how do you do this? Through MPC magic, you get to do this while keeping those inputs private to each of the party. So they get the output, they keep their input private, they're happy, and that's what MPC does. And if you want to know about more low-level details, we can go. I can explain a little later. But what's important here is you remember that just now I explained about those half keys being derived from 2PC, and that is important for us to use in encrypted communication. This is the original TLS encrypted communication. So it's pretty simple. You have only one key on each side, and they use it to encrypt and decrypt stuff. But because we have those two keys now in TLSNotary, instead of just one party doing encryption and decryption, as in from the prover side, you have the prover and the verifier doing encryption and decryption together using half of their keys with 2PC. So why do we do this? The reason is because if we are doing this, then the prover, who is the user, can no longer create the requests by themselves. They always have to rely on the verifier, other half of the key, to create or encrypt the request. Because they only have half the key, they only have the yellow key. So they need the other half, which is the red key, to do the encryption. And after the encryption, you have the request ciphertext, basically just meaning you have the encrypted request that can be sent to the server. So it means that the prover cannot just unilaterally send requests to the server. He always have to involve the verifier. And at the same time, the verifier cannot see the request because the request is also a private input of the prover. And what this means is that privacy is preserved because only the prover can see the request, which means your API keys, your auth token is all private from the verifier. And then finally, the prover sends the request to the server. Decryption works pretty similarly, but I think this is the more interesting one because decryption means how the user decrypt the response from the server. The response has the data the user want to prove, like bank balance and whatnot. So the prover receives the encrypted response from the server. He can't decrypt it himself because he only has half the key again. He has to rely on that verifier red key to decrypt together. Also, the verifier cannot decrypt on his own. Once it's decrypted, that response plain text that actually contains the data, it's also only revealed to the prover. The verifier cannot see anything. So privacy also preserved. And yeah, in this process, there is some commitment scheme that's being used inside the decryption 2PC that guarantees the fact that the prover cannot forge the response, and the verifier can trust that the response being decrypted is the original response from the server. So that's how verifier can guarantee that the response is not tampered with by the prover. Yeah. Before I go to the next slide, any question? Sorry, it's a pretty long presentation. Yeah. Because you wanna create a proof of this, a proof of the prover's data, and if the prover is able to just construct on his own, then he pretty much has to be able to. Let me show the other slide. To be able to construct the request on his own, he needs to have the full set of keys, right? Like he needs to have the orange keys. If he has the orange key, then pretty much he can do the encryption, which means that later on, he can just, because it's the same key that's being used by the server and the prover, right? So you have the prover owning the entire set of the key, and whenever he want to prove that data to someone else, he can actually decrypt that original encrypted response, change the data inside, re-encrypt it, and also there is some hash map generated in the meantime, and then he can just show a proof of fake data to a verifier. So you want to disallow him to be able to do this encryption and decryption on his own, so that this other party can be involved and guarantee that he doesn't do anything shady. Yeah. Is that clear? Oh, okay.
So maybe this is kind of a bit extra of a question, but so what if the prover is down and then the verifier wants to verify something? So in reality, is it multiple provers will exist, or is there a incentive for the prover to run?
So the prover is run by the user himself. So later I will show the user flow. So the user is like end user, like you and me, who want to generate some proof about my bank account or whatever data. So I would have the incentive to like run this little. So we have like a browser extension built as the prover. So as long as you run that browser extension till the end, then you get your data. If you don't run it till the end, then you don't get your proof. Sorry, you don't get. I mean, I said data, but I meant proof. Yeah.
But the verifier has an incentive as well.
Yeah. So if you are running a verifier, then you are someone who wants to, like Bob, who wants to check that this guy has enough money in the bank. He would have to spin up that verifier node. So this one is a more heavy node that you have to spin up, and you have to like run it so that you can get the proof, as in you can check the proof. Yeah. But if either party like stop doing what they're supposed to do halfway, then it wouldn't be complete and the proof wouldn't be generated. Yeah. Yeah.
I guess like meaning if I want to prove the same data to different parties, I have to repeat the process of doing the key generation with different verifiers.
So yeah, very, very good question. I'm going to cover that in the next slide, where we have a generic verifier that can verify some arbitrary data. And yeah, I will talk about that later, but then we have a generic use case where you don't have to like do this verification multiple times. If like all you want is just proving your bank data and it has multiple different things, and then you want to show it to different verifiers, you only have to do it once if you use the generic setup. Yeah, okay. But I'll cover that later. Yeah.
Sounds good.
How long does this proving process take? And is there any additional hardware requirements that you need to run?
So currently the limitation that we have is I think maximum 64 kilobytes of data. So this is more constrained to more simple text-based API response that you can prove. Like you can't. So we call it notarizing, which means just generating a proof. You can notarize like textual API response, but you can't notarize a picture, or you can't notarize like a really huge data, or you can't notarize like your past 10 years bank transaction, which might be more than, I don't know, a gig or something. And that's because of the technology underlying the MPC stuff that I was talking about. And basically that requires a lot of bandwidth and a lot of computation. So we are also making improvements on the core protocol to improve the speed and reduce the bandwidth required. Yeah, but the limitation in terms of generating a proof is limited to the amount that the 64 kilobytes that I was mentioning. And additional hardware, the prover essentially, I think we imagine most of the use cases would be browser based because people wanna access like server data. Normally, we use a browser, and so we have built a browser extension as an example, a proof of concept. So a browser extension is not additional. You don't need additional hardware to run it, but for the verifier, you would need a decent hardware. But yeah, I can come back to you later. But I'm not sure exactly what's the requirement of the hardware to run a verifier. Yeah, but we have. I think that's more for like industrial use case. If you try to like verify, I don't know, for 1,000 users at the same time, I'm not sure about that hardware requirement. But if you're just doing like for like a few to like 10 users, then we have tried just using a normal EC2 instance in AWS, and it so far works fine. Yeah. Any other question? Yeah.
Can the encryption process or decryption process be done asynchronously? So do they have to be doing it at the same time?
This is an interactive protocol, so it will be carried out at the same time as far as I understand. Yeah, so, and also there is I think there is some, actually I'm not sure about this. Yeah, I wanted to say there is a timeout in terms of establishing the TLS key exchange part, the earlier part.
Yeah.
But then once you have that done, then there's actually not much reason to do it asynchronously, because as the prover, you essentially just send a request to the server, and the server responds with a response, and that's it. So it's just two ways, and But good question. I can dig into more details.
Okay, cool. Thanks.
For the prover, which is basically the user, when they receive the SSL certificate from the server, in general case, the client would verify it, but in this case, would the verifier also need to verify the SSL certificate?
Yeah, the verifier would also need, so the question is if the verifier needs to verify the certificate of the server. Yes, that is included in the proof, the identity of the server as well as the public key of the server. So because as a verifier, I need to know that your data comes from a legit bank. And for me to know that, I need to know it's from this bank server with this public key, which I can verify online. Yeah. Any other questions? Nope. Okay. I shall continue. So I've given this talk for maybe about 20 minutes, but I haven't mentioned Notary, which is inside the TLS Notary name. So now's the time to talk about Notary. Notary is a generic verifier, basically. And what that means is this Notary is kind of like a layman term would be like a vendor that helps you run this whole MPC-TLS stuff that I talked about just now on behalf of the verifier. So this Notary needs to be an independent and neutral party, ideally, so that he cannot collude, or he doesn't have the incentive to collude with any user to generate fake proof, because he can. Like, if the Notary is malicious, then he can collude with the user to create fake proof, because they are the ones that, like, Notary now becomes kind of like the verifier. And though the Notary can't see any plain text data, as I explained just now, as well as he actually doesn't even know the server identity. All he received is just the public key of the server, which doesn't reveal the identity of the server. And he also just received the other thing that he received, it's encrypted data that is like passed along in the TLS process. So privacy is preserved, and the verifier should only accept the proof generated in this setup if he trusts the Notary. So we imagine Notary being run by people like, can't remember the exact name of this neutral, I think the party that runs Internet Archive, they are like kind of neutral. So we think that they are a potential candidate to run a notary. PSE has our own notary, but we are having it there because we want developer to build stuff with TLSNotary and they can just use it. But yeah, it's public and you can use it now. And yeah, so you might ask why we do this setup, which I'll cover in the next slide. But first, let's talk about what this proof is. So we talk about this proof that the verifier can verify, but what it actually is, it's a transcript of the request and response that has been passed along the server and the prover, who is the user. And yeah, it's pretty simple. It contains the request body and the response body and the headers, and also some TLS information like the public key of the server and some handshake details. So this transcript is eventually being signed by the notary, but notary doesn't see this request and response body in plain. He only signs a portion of that transcript, which is all encrypted. So he doesn't see the plain text, and again, privacy is preserved. But you can rest assured that the signature guarantees that this response actually comes from the server. And again, that's due to some commitments that are being done in the MPC setup, which I can go a bit deeper if you guys like to, if you have time later. And yeah, so the reason why we have this notary setup is because of also what Kaijun asked just now, where if this prover has he wants to prove different things in his data, like maybe his bank data contains different things like his name, his address, his bank balance. He doesn't have to do that verification like 3 times. So he can just do it 1 time with the notary. And then the output of that session would be, the output of that notarization session would be the authenticated transcript, which just means signed transcript. And then now he can just pass this transcript to different verifiers. And these verifiers just need to verify different parts of that transcript, like his name, his address, his bank balance. And yeah, the only thing here is the trust assumption that the verifier needs to have on the notary. So I mentioned about privacy a lot of times, and I think this feature that we have is really crucial to preserve privacy, which is the prover can selectively disclose data on the transcript. Like I mentioned just now, where that one authenticated transcript contains multiple things. And maybe it has the name, the address, the birthday, but then for one verifier, you just want to prove your name. So you can just redact your address and your birthday because he doesn't require it. And for the other verifiers who want different things, you can redact the non-required parts. So this is enabled and supported by TLSNotary. And to take it even further, you can basically skip redactions and just use ZK. And essentially, you have a commitment to the transcript that's signed by the notary. And then what you do in the ZK circuit, is that you prove that your response hashes to that commitment. And then after that, you pretty much can prove anything within that response to the verifier and not review anything. Essentially just proving a statement, like proving that you're above 18 years old without revealing your age, proving that you don't live in US without revealing where you live. So that's kind of like the ultimate private ability. Yeah. So far, so good. I think question time for the notary setup.
So regarding the redaction part, if a user can just redact any parts of the transcript, can they also modify it? I assume they can't, but how?
So this part would be, so this part is done by the user, which I will show later in the demo. So in the beginning, if you use the browser extension, you will see the payload that's written from that API that you want to call, and then you can just highlight the text that you want to redact or you want to reveal, then everything else is redacted. And the reason why it's not possible to be tempered by the user is because the redaction ranges is done before this whole MPC stuff happened. And during the MPC setup or that MPC progress, there are commitments of these ranges that happen within that process. And in a way, it guarantees that these ranges are authentic and comes from the server. And the notary also signed some encoding that correspond to these ranges. To explain that fully, we have to go back a bit to garbled circuit, which is the primitive used by 2PC and MPC, so that you can get a full understanding. But yeah, essentially this redaction wouldn't allow user to temper the data. But yeah, to explain it in more details, we need to revise a bit of the primitive that's being used to understand it better. Yeah.
One more question regarding the trust assumption. I think we are also, in this setup, we are also trusting the server to give the right response to the user's request. But what if the trusted server made a mistake? Like, for example, the bank account has 1,000 ringgit, but right now the bank suddenly returns a response of 1 million ringgit. Then I can use that response to be part of the proof, that I can prove it to whatever verifier out there. So would that be a disaster?
Yes, that's a very, very good comment. TLSNotary doesn't guarantee the accuracy of the data that is stored in the server. So if the server is hacked and your bank balance increased by 1 million ringgit, and you use TLSNotary, you'll be able to prove that you have 1 million ringgit without any issue. So it only guarantees we call it data provenance, like where the data is coming from, but not the accuracy of the data. That's the responsibility of that server that you're interacting with. Yeah. So that's like an issue if the server get hacked. Yeah. Any other question about notary setup? Nope. Okay. Yeah. So how can you use TLSNotary right now? The core library is built in Rust, and we imagine the prover would usually be run in a browser environment. So we also have a WASM version that you can run. Same for the verifier, and the notary is also available as a Docker image to be run. And to demonstrate this, we can do a little bit of demo. So this is quite quick, actually. And give me a sec. Let me find my mouse. Oh no, I lost my... Okay, I will... So... Yeah, just to show you, this is actually all documented on the website of TLSNotary website. And I'm just like going through these steps. So you can like follow this if you're interested back home. I can give you the link later. But essentially, we are downloading the browser extension from our GitHub repo. Yeah, we have a few versions released. This is the latest one. So this is the extension that you can download, and so you can just click this zip file you downloaded. I already have it downloaded, so it's here. So you have this zip file downloaded, you unzip it, you get this folder, and then you go to your extension in your Chrome browser. Oh, the extension is for Chrome and any Chrome-based browser. So I'm using Brave, so it works as well. You load, I think you have to turn on the dev mode to load Unpack. And then you can load that folder. And then what you do is you could click details. This is really hard for me to see actually. But you can pin to toolbar so that you can access it on the toolbar. And then, yeah. So you have it here. If you click it, you see that there are two examples. where you can notarize or prove your username of Twitter, or you can prove your username of Reddit. So you can just click like this button. So you go to Twitter, which is my Twitter. And then if you click notarize, it's going to start the proving process. Yeah, ignore the background. I don't know what's on my feed. But yeah, this is it running. And just to give you a bit more information, that Notary API is using our the TLS Notary that's running. And there is this proxy API. It's not that crucial, but essentially we need to have a WebSocket proxy because of some limitation of the browser. But this will take some time because this notary is located probably in Europe. And as I mentioned, it takes a lot of bandwidth to do a proof. So because of distance, there will be some latency delay. But you can change this API, this endpoint to a different one. So let's say you want to use somebody else's notary that they run in the future, then you can change it to that. We can also change it to a local notary that you run on your machine. I mean, that's not very helpful in the production environment since you want the notary to be a neutral party. But for demonstration, we can change this to a local one, so that's faster. But yeah, what's happening right now is, so sorry, I clicked the wrong thing. History. Yeah, so now it's done. So what happened was your prover, which is running in your browser, is interacting with the notary that's run by TLS, and then it's sending requests to Twitter to specifically this API, account/settings.json, which contains my username. And if I click view proof, I'll be able to see that this is the request body, and you see everything is redacted. This is the default setting, by the way. So it redacts almost everything, like the API tokens and cookies and whatnot. And then if you click the received part, you will see my username, Christian Tiki, and everything else is redacted. So this is just the default setting, but you can do a bit more custom. You can do a bit more customized requests. So if you click into requests and you just reload the page, you should see all the requests that are being fired from your browser to Twitter. And of course, all these are local, so it's not being sent to any server, in case you're wondering. You can find the API that contains the data that you want. But for my demo, I know I'm going to use this account setting.json. So in here, I can see the request headers that we used to send to the server. And also I can see the payload in the request as well as the response. I can click fetch response. And I will see a bunch of headers that are being turned as well as the data. So yeah, my screening is here. And then there are a bunch of other stuff as well. So if I found my data that I want to notarize, then I can just click notarize. And then here it will ask me to whether I want to review any of the request headers to the verifier. So I can, for example, say I want to review the origin. And then that's it. And then now it asks whether I want to review anything within the response body. So let's say I want to do something else. Maybe I want to prove my time zone. This is quite useless, but let's try. Okay, whatever. I'm just gonna go with this. So it will review this part, and then the rest will be redacted. And then if I click notarize, yeah, so it will run again, doing the MPC stuff with the notary, and then sending requests to Twitter, getting a response, and then also doing some commitments being generated in that process, where the notary will sign over the transcript, and then eventually what you have is that proof that you see. So there is also a website to visualize the proof. So if I go to my extension, go to this, download that proof, and then I go back to that visualizer. So yeah, this is another proof of concept that we built, and you can upload your proof here. And then, yeah, so now it says signature error because we are using the TLS notary server. So you have to click this that has the right public key, so that checks the signature. And then now you can see it's just a pretty way of seeing a proof. The requested server domain, the requested headers, and the response headers, as well as the response body, and everything else affected as expected. So yeah, I think the other guy should be done now. Yeah. So to review the proof, you should only see, yeah, we review origin. I think post and accept encoding is reviewed by default, and connection as well. And then the receive should have, yeah, the Asia Kuala Lumpur protect key stuff. Yeah, but that's pretty much it for the demo. Any Let me go back to this place.
Yeah. Out of curiosity, you mentioned that right now we're running a notary service. It's essentially you want a neutral party to do it, and that ensures that no one have the interest of exploiting it, right? Is there any incentive for anyone to do this, or what's the idea around someone doing this, other than willingness in making the world better? Yeah.
So the question is whether is there incentive for someone to run a neutral notary, right? I'm not too sure about this. I think from what I heard from my team, they are saying that those neutral parties, like the guys behind Internet Archive or like the guys behind some, I can't remember what's the other example. They're willing to do so because what I understand is also just because of like the positive motivation to help to liberate user data from Web2 servers or any TLS server that has data siloed inside. There might be, so I've heard of ideas on there will be a notarized proof marketplace in the future where people could, I don't really understand how it works, so I shouldn't talk too much about it. But if you think of such marketplace existing where people have incentive to like trade notarized proof, then there might be incentive to run a notary. But that's a fairly, yeah, you shouldn't trust my words on this because that's like hearsay. So yeah, it's purely my opinions and not representing PSC. Just to be safe.
And thank you for sharing anyways. So another question I have, following that up, you also mentioned that running your own as what you said, running your own local notary is not as useful as running it on a neutral party, right? Is there any way of making a locally run notary trustless enough that someone running it can, like, we no longer need to rely on a neutral third party? Is there a way of making that completely trustless? I'm just curious. Yeah.
Yeah, so there are two alternatives. I'm not sure if you've heard of or you got to listen to this part where I was talking about the verifier setup that's not notary. So if you are a verifier and you want to verify some user data, you can run the notary yourself, because the notary essentially it's a special case of a verifier. So if you are doing this MPC-TLS by yourself as the notary, as well as you are checking the user data, then you have no trust assumption because you're the one that's involved in this whole setup. So that's one way. The second way, if you want to run a notary in a trustless way, we are also exploring running it in TEE, Trusted Execution Environment. I think that's what it stands for. Yeah. And which means that this software is run in this environment that's guaranteed where no one can influence or change its code without being infected. That's my rough understanding of what it is. Yeah. Other question?
So what's the next step for TLS Notary? And how would you are you planning to put it into production, or are you just like gonna do like a paper and demo and then let people come follow up on it?
So the question is about what's the next step for TLSNotary, whether we'll launch it to production, and yeah, what's the next steps, I guess. So right now, from an application level perspective, we have this extension that I showed you just now that's running. We want users to use it, and we also want people to build more use cases with it. So that's why we built that extension as an example. And that one is really, actually, I'm not sure whether it's really like in Chrome store that you can download. I think it is. But it's also like pre-release version, like very, very early stage. From the perspective of the notary, we're running one that I was showing, like just a point like that. It's actually by us. That one is also to we are imagining it to be used by more people in the future, and it's already out in the public. So when there is more users, we might have some kind of this is still in the idea stage, but we might have some kind of authentication to make sure that not anyone can directly connect to it, so that we don't spam the server. Yeah, and we also imagine more entities, more neutral parties to run virtually, as what I suggested just now. And then, and also that's really like in the public, so we can really use it. So yeah, I guess it's live in some sense. And then from a protocol perspective, we are trying to improve the latency by incorporating new cryptography techniques to reduce the bandwidth required, so that you don't have to wait. Like we were waiting for like, I don't know, 10, 15 seconds just now to get approved. Yeah, so that new technique that we're thinking of incorporating should result in 100x performance. So yeah, that's in the pipeline.
Any plans to kind of maybe do a bounty or put it as part of hackathon? Maybe we can do it in ETHKL October hackathon.
I think it was part of ETHKL last year.
But specifically TLSNotary?
Yeah, TLSNotary. Yeah. It's been how should I say this? We sponsored a few hackathons, like last year ETHKL in New York, and then ETHKL. And then this year we're going to ETHDAM, and then if Global Brussels as well. And then obviously DevCon, I'm not sure whether we are sponsoring the prize.
Okay. Can you share any projects that are using TLSNotary now, and how are they using it?
Yeah, question is about how is there any project that's using TLSNotary now? So there are actually two that we have given grants to. One of them is using TLSNotary to prove that user has made fiat transfer to a bank account, and then they are using that to on-ramp someone. So giving that person crypto in exchange. So yeah, it's called TLSN on-ramp. There's another one that used TLSNotary to prove. So essentially helping hackers to get their bounty for vulnerabilities. Because I think the pain point that he was trying to address was hackers nowadays, when they find a vulnerability in an API, whenever they want to reveal how they do it to the company, there'll be like a chicken and egg process where they want the company to pay them, but then they don't want to reveal the secret first, and then the company wants them to prove that you know how to do it, the trick, before I pay you. So he's saying, I think he's using TLSNotary to notarize that hack, because it's over HTTPS, and once you get a response, you can clearly see that it's being hacked. And then that is the proof. And then through some threshold signature stuff, you can like prove that this hack is legit, and then the company will be able to trust that and then release the fund to the hacker. Yeah. If you find out more details, like, I can talk to you offline, but that's the general idea.
One question, right? Just now you shared one thing is basically you can generate like ZK proof, or whether, for example, the age past 18 or something. Is it available on TLSNotary now, or is still like in the roadmap? Just curious for this one.
So yeah, this is actually the part that I'm working on right now. So it's still in progress. We are hoping that it can be out soon. Yeah.
So given in this case, right, then how does it change the overall process? Like, like in what specific case we need to define whether let's say the birthday one, right? Want to like in which specific process you're going to define that, okay, as long as 18 plus is good, like, because now we only can censor, right? Technically censor and show. In this case, it's like half declaring in some sense, like we don't show the real data, just we show some information regarding it, like how this affects the overall current TLS notary flow. Like, yeah.
It doesn't affect the whole MPC-TLS part because this is, so there are like two parts. One part is where the verifier is collaborating with the prover to generate, to encrypt and decrypt stuff. And then the second stage is where the selective disclosure part comes in. So this one is a simple one, like the redaction use case, redaction ability. This part is where, so what you're seeing right now wouldn't be built directly into TLSNotary, like proving inside the transcript that you don't live in the US or proving that you are above 18 years old. This can be built by someone else, someone who has specific use case, like someone who wants to check whether you're not in the US. So what TLSNotary generates is essentially a commitment of the plain text, and that commitment can be a hash of the plain text. That hash is being signed by the notary. So the output is a signed commitment by the notary. And with that signed commitment has to be ZK friendly because some hashes might not be ZK friendly. I.e., it cannot be easily done in a circuit. Some other hashes are more friendly in ZK. So we are generating those ZK friendly commitment. So this ZK friendly commitment is it's also like a portable proof that the user can carry around. So the user can carry this signed commitment and then use that in another ZK circuit to prove things within that the data that is the committed data. Yeah, because in the circuit you just have to prove that your whatever plain text response you have hashes to this commitment, and the commitment is a public data, and the plain text is private data into the circuit. So yeah. Okay, I think that's pretty much it. This is the links to the website and the documentations. The QR will link you to the website and more data there for you to see. Thank you.
Okay, so everyone, let's take a group photo and then we can start to eat pizzas afterwards.